Bueno,
For those who were here during the previous talk, I was present at the concert in the School of Engineering, and what he told about was something that I lived when I was younger. And sometimes there are songs or books that change the way in which we see things. In 91, I listened to Nos, the quartet Nos, and they changed the way in which I looked at humorous things. And there are also books that change our perception with regard to certain topics. Let's say that you've read Macbeth, and that Lady Macbeth is as evil as you can think of someone, a woman who was a murderer, really complicated and manipulative. But one day you read Richard III, and then you realize that your concept of being evil has changed, and you could be much, much worse. Richard III was so evil, and that he changed completely the definition of being evil. And today we are just trying to reach him 500 years later with our definition of what evil is. And why do I say all this? Because I read a book that personally changed my vision of what I understand for computing as something big, and how to approach things from a computational point of view. It's this book, Machine Learning from Tom Mitchell, which was published 20 years ago, in 97. And I heard about this book for the first time in 2002 at a seminar organized by my friend Nogarat, and it was a seminar on something that we were not very familiar with, machine learning or automated learning. At that time, no one knew what that was. And what we did was to get organized in order to study and present one chapter each. And I had to talk about decision trees, which is a simple method for making decisions. But what happened to me was that, and that's what I'm going to try to convey today, was that this changed my vision on how to do things. It was based on what I had learned, but really different. There was a problem that was analyzed in the book. It said, well, I know what the weather will be, and I know whether Nicolas is going to play golf today or not. Most of us, I'm certain, would think, we developers, I mean, would think on how to develop software based on the weather to decide whether Nicolas is going to play or not. And since it's complicated to play with on a wet course, we would build this tree that is a chain of ifs. It's in English, so you'll see it here. If it's sunny, there may be humidity or not, there may be wind or not, yes or no. The important thing is that decision tree is based on what we know about the world. But Mitchell's book, actually the idea came from the past, long before his book, was to change our mind frame. And instead of basing our decisions on what we think the world is, to base our decisions on experience. Because I know what Nicolas did during the past 15 days and whether he played or not, golf or tennis. A series of attributes were taken, And on the basis of these data and on the basis of experience, and forget about neural networks and decision trees and divergence methods, all of these are methods to solve this kind of problem, which is a problem of classification. So, based on this data, we could build this same tree, but in a completely different way. Instead of having a model of the world, we could infer things from the data. This completely changed the way in which I saw things, because it opened a series of possibilities, especially when we have data. It changed my mind frame, and also it made me think that I had seen this before. And I remembered Francis Bacon, who in 1620 wrote a book where he said there's two ways of finding the truth. One of them is to assume that there are general principles flying away from particular cases and then deriving these principles to other cases, and this is what is more or less fashionable right now, although Aristotle started with this idea. And the other thing is start with the particulars and infer the general principles. And this is what is called inductive methods, which may be used at high school. And what he was doing was to found a scientific method. So this is something similar similar to automated learning, which is nothing more than the development of empirical points of view for decision making. Mitchell's book was not new. These are the method it mentioned and the years in which they appeared for the first time. But what was new in his book was the definition of automated learning. And his definition was a computer program is set to learn from experience with some class of tasks measured in a certain way, if the performance improves with experience. And this is the big difference in automated learning, which is essentially the definition that we have today for artificial intelligence, which is like a mobile target. The definition changes from time to time, but it's something, a computer program that improves with experience. And in automated learning, there are three main tasks. I'm going to describe two here. And this is my Spotify screen. Spotify is probably the best example of automated learning I know, although it was Netflix that invented it. These are the suggestions that Spotify is making. Spotify is suggesting these songs based on what I have been listening to. And this is part of a classification problem. It takes all of the songs out there and gives each one a number based on what it believes is best for me. And this is done based on experience, that is to say, what I have been listening to. And here they suggest Paul Simon, etc., the kind of music I listen to. And it's not so simple, because the Spotify can suggest all the things I listen to, but that's not very funny. They have to fulfill my preferences, but also take some risks. And we could write a whole presentation with regard to exploration and exploitation. because I can do two things: either take risks from time to time or play it safe. And I have a problem, maybe you have it too. It's that we listen to different kinds of music, classical music and Fernando Cabrera and Cita Rosa or Manu Chao. If Spotify gives me a list of all of them, then it's a problem because it's not very good suggestions. So Spotify groups songs, and that's clustering, which is the second task of automated learning. So Spotify groups similar kinds of music. And defining a cluster is difficult even for human beings. So here it has put, for example, Ruben Rad and the North Quartet, and here it has a problem. What happened? Well, a couple of weeks ago, I was listening to Comical Virtue, and I altered the musical habits, and Spotify is doing the best it can. It tries to group everything under Uruguayan music, but it doesn't do it explicitly. There is no software that makes these decisions. What it does is clustering. It groups on the basis of the data it has similar songs, but when I add new ones, probably this is going to disappear, or else I will make a daily mix of different kinds of music. So this is what clustering means. But the important thing is that even clustering improves the experience. This is how it works. It's not that it's wrong, it's that it's improving with experience, and this is machine learning. There is a third line. This is Super Mario. The problem is that the guy that is handling Super Mario is not a person, but an algorithm that learned to play. And if I'm not mistaken, plays Super Mario better than human beings. The way it has of playing is learning by reinforcing. And this is what is going to change the world of robotics. Instead of learning from previous experience, like the golf game, it has a method of trial and error. If it finds the wall very quickly, it can learn to take another road. And this is how the Super Mario has been trained. Now, how good are we at this kind of exercise? For some, we are really good. This database has been done with numbers from the US Census, and it's the MNIST database. 60,000 examples for training and 10,000 for testing. So the task is to recognize the numbers. And this is called supervised learning. This used to be a task that was really complicated, but now it's almost an introductory exercise. And these are the performance grids. The lower, the better, because it shows errors. And the dotted line represents human beings. And the computers have already reached with their algorithms the same level as human beings. This is artificial intelligence that we're seeing here. So for a developer, this means that recognizing a number is something that a software does as well as a human being. If we look at these photos, you will see here drawings and photos of airplanes that have been identified. The photos are really small on purpose, and the task is to tell which one is which. And our performance of the performance of the computer is up here. Computers are better than human beings at the moment in recognizing these kind of images. For example, recognizing whether there is an airplane in a photo or not. They do it better than a person. And let me make a clarification. From there to general artificial intelligence, the possibilities are endless. But in this task, the computers are really good. How do they operate? What we see here is a neural network that uses deep learning. They receive the image and they make many calculations, mainly multiplications of matrices, and this requires algebra knowledge for us because we will have to add matrices in the future. So this neural network multiplies matrix, and on the basis of the dots in the image establishes certain categories. And with this kind of method, we are achieving performances like the ones we just saw. We have faster computers, better algorithms, and mainly we have better data. That's why they can do it. And this is a link for the tasks that are being done today with artificial intelligence and the true results. And in some things, computers are not so good. For example, answering questions from real life. Now, most of you are developers, so I thought I should give you, very humbly, 7 tips. So these advice for developers are really useful because they are part of our change process. We understand that all this is going to change in the future. For me, at least, this is true. Beyond the data and all the noise out there, in the short and the long term, these are the changes that will take place. Firstly, understand what this is about. Don't go out running to read about neural networks. Understand the kind of methods that exist, how they operate, what's the point of departure, and how, based on data, we can approach problems. 2. Think whether your problem can be solved or improved on the basis of experience. For example, with regard to Spotify, I could improve things because I know reality from experience. If I have experience in people's tastes, then I can make recommendations. This is what Spotify does, and it becomes much more useful when we have data. But we have data about almost everything. And we have the possibility of generating experience like robots or Super Mario. I make him play and play and play, and he crashes against walls, but that experience is stored. 3. Think whether your sub-problem can be modeled through classification, regression, or clustering. Maybe I can turn around a problem so that it becomes a problem that can be either classified or regressed or clustered. For example, a song generator. If I turn things around, it can be seen as a classification problem because I can say, given a 15-word sequence, and that's actually what's used, probably the next one will be X word. And this is a question of classification. And regression is assigning not a category but a number. So we have to turn things around to say, oh, this is a classification problem and I can base the solution on experience. Then you'll have to learn to measure all the time and live with uncertainty too. Empirical methods force us to understand that reality is noisy, and in between, I have the right to listen to cosmic night. The world is noisy, there's no perfect solution. I have to measure and see how my performance improves, and see that the data not only suggest things, but they also validate them. Validate those things that actually function as I expect them to work. This is not new, but in machine learning, it's necessary to automate everything, to automate these things, otherwise they lead to errors. And be careful with overfitting. After 2 days of working, you run the risk of overfitting. For example, a friend told me I bought a washing machine from Amazon, and Amazon now thinks that I'm going to start a washing machine collection. So I just bought one washing machine, but Amazon is generalizing. And also, you have to understand the limitations of these methods. They are not magical. For example, they cannot learn more than what the data are saying. And sometimes they reproduce the behavior of the data, which leads to discrimination in some cases. Automated learning methods are not capable of innovating. They find it much more difficult to do things in a different way, although they are good in repeating experiences. And finally, machine learning is not so much a question of big data, but a question of algorithms. What do I mean? The important thing is to reason on the basis of data. And for some problems, having more data is useful because they learn on the basis of data, but we don't need Google to do machine learning. Finally, I would like to leave with you this reflection by Andrew Ng, who is a professor in Stanford, and he's almost a legend with regard to machine learning. Now he's left Stanford, and it says, if you're trying to understand artificial intelligence near-term impact, don't think conscience. Instead, think automation on steroids. We are capable of automating things that we could not automate in the past. On the basis of data, we can automate things that involve predictions. We are much better predicting than before. And this is going to change the behavior of the whole industry, the behavior of every single thing, because now I will be able to do things that were unthinkable in the past, like recognizing images or saying, for example, you're probably running out of washing machine powder. And based on experience, all this information will be available. Everything that involves predicting will be done on the basis of databases. And we have to understand how it works in order to put it in our daily life. Otherwise, we will be unable to survive from this point of view. Thank you very much.